Hello and welcome to Cracking the Cryptic, and I had a quick count. I make this the 64th of our bonus day double video extra content videos, so welcome to that, and we will continue doing it while we're in lockdown, which seems set to last for a few more weeks, at least 3 or 4. So carrying on then, today I'm going to be trying an odd even killer puzzle by Jeremy Butler, which I've got some trepidation about because our test solver really struggled with it. Actually, it turned out he was missing one marking, so we don't know whether that's going to be the key point or not. Let's see. Now, just before I do that, I do want to alert you to a post on our Patreon page if you're interested in crosswords at all or puzzle hunts, because Matt Gaffney's wonderful series of meta crosswords combines the two, and I've done a little video about the last 3 weeks of it, which have been very interesting, building up in difficulty as they do towards the end of a month. They don't solve all the crosswords, they just look at the end games, which is quite good fun actually. So do have a look at that. It's on Patreon, it's not behind any sort of paywall. You can just have a look at it if you want. But of course we do urge you to join the channel as a Patreon and pay $2 or $3 a month at least. Now, all of that said, let's have a look at this odd even killer puzzle, for which the rules are, it's a killer Sudoku. So all the cells are covered by cages. Now the cages have to have different digits, and where the cages are coloured in any way, grey, yellow or green, they are runs of consecutive digits, like Ren bands, if you know that. So this cage here that is 5 digits long is consecutive digits, not necessarily in order. Now, where there are white cages, they don't fulfill that parameter, so they are not all consecutive. Obviously, some of the numbers in them could be consecutive, but they're not all consecutive. Now, the blue cell is an even number. There's just one of them. And the only other thing to say is that where sums are given in the cages, their digits have been replaced by E for even, O for odd, or a question mark for unknown. Why are there different colours of cages? Just because in our software that helps distinguish them, not for any other reason. So green, yellow and grey cages all act the same. The blue cell is an even number, as I said. So those are the rules. Do have a go at the puzzle before watching the solve if you're interested in giving your brain a workout. I think it's a tough one. We'll see. It's on the link below the video. But with that, let's get cracking and see how we get along. So, where on earth do we start? Okay, this is a 3-cell cage here with an even number beginning it, which must be 20 something. And it's coloured, so it's a run of 3, so 987 would be 24, 876 would be 21. It has to contain 8 and 7, and it's selected from 9, 8, 7 and 6. And then below it, in the same box, this cell with this cage with the even number, we've got a 2-digit number. So it must begin, well, sorry, no, it must, 654 is the highest it could be given this cage, and that's 15, that's possible. 543 is 12, that's also possible, but 432 is too little, that's only 9. So this has got 4 and 5 in it, and it's selected from 3, 4, 5 and 6. Now that means that 2, 1 are both in those 3 cells, and they can't both be in this one because they'd be consecutive, it wouldn't be white. So that one is 1 or 2. Okay, this one contains 1 or 2, but also something else. Could even be 3, this could be 1 and 3, so can't make any further use. Now this cage has to have 3, 4 and 5 in it, and can't go higher than 6 once this is 1 or 2. Could be a 1 actually as well. So, and it must have 3, 4 and 5, although 4 and 5 can't be down here. So 4 and 5 are up there. Oops. Are up there, and 3 is in one of them. But then what? Okay, this can't have 3, 4 or 5. So it's from 6, 7, 8 and 9. It's another run of 3. It must have 7 and 8 in it, just like the other one over there. But once we've said that, oh, whatever this is must be in one of these two, 1 or 2. Can't even pencil mark that. I don't have the ability, but okay, yeah. Where? Oh, look. Yes, okay. Single digit marks. They're very important. I've worked that out now. This one here is ruling out a 9 from this cage because it would immediately break as soon as you put another number in. So 9 must be in this cage. Let's get rid of the corner marks. That's 9, 8, 7. This could still be 1 and 3, but it could also be 6 and either 1 or 2. Okay, but these single digit marks, look, there's some in 3-digit cages. 3 of them. They've all got to be either 1, 2, 3 or 2, 3, 4. So I'm going to mark them all up. Oh, so use the mouse, man. Use the mouse. Right, they're 1, 2, 3 or 4. So these cells in that row are 5, 6, 7, 8 or 9 because the 1, 2, 3, 4s form a triple. And here, that's nice. These ones are consecutive. These ones are not consecutive. So they must include the 5 and the 9. That's right, because this is either 6, 7 or 7, 8. So the 7's in there, the 5 and the 9 are in there. These can't have the 5 and 9. These can't have the 7. We've got 1, 2, 3, 4 in the column as well. What does that do to this? Oh, nothing. In fact, we don't need this clue at all. This can only add up to 11, 13, 15 or 17, so the clue's not very helpful. Oh, yes. This is either 1, 2, 3 or 2, 3, 4, so it includes 2 and 3. So that's not 2 or 3. In fact, these two are 2 and 3 to go with either a 1 or a 4. So that's not 2 and 3. Same again. These two are 2 and 3. That's quite nice. This one is not 2 or 3 because they're now in the box. So these two are 2 and 3. So that's what it looks like. That's quite neat. And look, we've got 2 and 3 there, 2 and 3 here. It can't be 2 and 3 in this one because it's white. So they can't be consecutive, therefore. So this must either be 2 or 3. This must join to it consecutively. Can't be 2 or 3. It must be 1 or 4. And look, this is an even sum in 1 digit. 4 and 5 have to be in these two. Sorry, an even sum in 2 digits. It can't be 4 and 5 because they would be consecutive. So it has to include 1 because 2 and 3 are gone in the box. So 1 is in there. Put it in the corner. And it's even, so it's with another odd number. Must be 5 or 7. So where's 4 in this box? It's got to be in this one because 4 here is ruling 4 out of there. And that's got to be with 7 or 9. Excellent. So now 6 and 8 are down here. And that means this doesn't contain 6. That's 3, 4 and 5. So 6 is here with either 1 or 2. It's not here. 3, 4, 5. So 5, yeah, sorry, I should have worked that out. This has to contain 5 because 5 has to be up here somewhere. Yeah, so get rid of the 7 from there. That is 1 and 5. So these are made up of 6, 8, 7 and 9. That's a run. This has to be even, doesn't it? Because that's 1 odd and 1 even. And that's 1 odd and 1 even. So this is even. But, oh, and look. No, 9 could be here. That's all right. I can't decide that. Wow. I mean, some progress. Now, might have to look elsewhere. And this cage is in, yes, that is an interesting sum. I was thinking that was going to have to be a 1 to begin it, but 1, 2, 3, 4, 5 would be 15, and the next number up is into the 20s. So that, I don't think it can be 15, because look, we've got 2 and 3 ruled out of 4 of the cells. So although that could be 3, the lowest this could be is 3, 4, 5, 6, 7, which is 25, and it's got to be as many as 30. So it could be 4, 5, 6, 7, 8, and 5, 6, 7, 8, 9 would end in an odd number. It's got to be 4, 5, 6, 7, 8 to be 30 something even, because 4, 5, 6, 7, 8 is 30. So we can get rid of the 9 possibility. 4, 5, 6, 7, 8. Almost running into those with an overlap, not quite. Okay. Oh, look, this even cell, that's been shouting at me for ages, as you have. It clearly can't be anything other than 4. Now we've narrowed this down to 3, 4, 5. So 3 and 5 either side of it. That can't be a 3. Can't be a 6 either, actually, because 6 is in one of those. Ah, so that's 1, 2 in this yellow cage. So the others have to be 3, 4, 5. Let's get them out of the corners. 3, 4, 5, 1, 2. So either 6 or 9 is in here with one of 1 or 2. Can't be 6. 6 is ruled. So 6 has to be in this cage because of the 6 along here. Yeah, so in fact this one has to be the 6. Got a second digit in the grid and we weren't even given a coloured cell. Right, get rid of 9 from that. 7 and 8 comes out. That can't be 7. 6 is definitely in here. We've known that for a while. Ah, this is interesting. 3, 4, 5, 6, 7, 8. So this is a 1, 2, 9 triple along here. But that doesn't really help. The negative constraint's not really applying here. I'm going to take 6 and 8 out of these corners because they're just a bit getting in the way now. Yeah, interesting. Now, 7, 8, looking straight at that cell, so that's a 9. And that means that 7 can't be there, so that's definitely a 4, 9 pair. So we can get rid of 9 out of there. 7 is in that consecutive cage. Oh, I can't get much more done. That one we've looked at, it's not particularly helpful. This is little, but, well, this is little. Maybe that matters. There's a run of 4. This is little as well. Yeah, so it can't have the 9. So the 9 must be up here. That can't be 9. 9's here and here. So in column 6, 9 must be in one of these. And therefore one of these 4 cell cages must be 9, 8, 7, 6. Actually, they both can't be, or you'd have too many digits out of 9876 in this box. So there isn't another 9. These aren't 9. This 9 means these aren't 9. That's not 9. 9 must be in one of those two cells. Ahaha, it can't be in this one because the box would explode. So that's a 9. Good Lord. Didn't expect to get at it that way. That's really weird. So this is a 9876 cage. That's quite interesting, because that gives us an 876 triple down here with a 9. Oh, this is 1, 2, 3, 4, or 5. I suppose that was always going to be small because this is a small sum. But if 9 was there, these would have to be 987, wouldn't they? 6, 5, 4, 3. Yeah, that couldn't be 1, 2, 3, 4. So this would be 2 and 1 up here. If this was 9, these would have to come from 876. We'd have too many 876s there. That's not 9. That is not 9. I think that's right. These would have to be from 876 to fit in the cage, and there'd be just 4 cells that would all have to be 876. That's not possible. So this is 9. Okay, so this is a 9876 cage. That gives us a 678 triple there. Gets rid of 678 out of those. Has that resolved? Hasn't resolved this box particularly, no. But 678 triple in the box reduces that to 4 or 5, and that's 4 or 5. So we can take 4 out of there, 5's out of there, and now we've got a 678 triple across here. So we're left with a 5-9 pair there. This is really complicated. This is now a 4 though, and that means at the other end of the cage there's a 5. That's not 5 anymore. 5, 9, 6, 7, 8. These are from, this is 1, 2, or 3, so this is quite a low number box. This is 1, 2, or 3 as well. I don't think these can be, these can't leave out the 1, because then 1 would be here with higher numbers. So 1 must be in this pair. I have a feeling, maybe it's been obvious from the start that this was 1, 2, given the setup of these, but I'm not going to worry about that now. That might be true, that you could just look at these top boxes. This has to be, yeah, these have to be 3, 4, 5, 6, because they've got to include the 3 now. So 6 comes out of these, and this is 6. That makes this 6. This can't be 6. This is 3, because we've got 1 and 2 there. This is 4. It's the last number left in this box. This is not 6, for 2 reasons at least. Yes, I was going to look at this, because now we've got 5, 9 eliminated. This includes, that's been resolved for a long time, so we can put the 2 in there. Is that unwinding everything? No, it's not. But it puts a 3 in here, and it's a single odd number, so that must go with 6. So it's got to be 3 and 6. Brilliant. So that really is going to disambiguate stuff. So we can take 6 out of here. These include 9 here, and 1 or 5 there, 1, 4 or 5 here. This is now 6, because that's a 7, 8 pair in the same cage. This is 7 or 8, isn't it? Because that's a 1, 4, 5 triple. Now, can we add these up to get one number or the other. We've got to have the 5 here, so that 9 and 5 is 14, plus 8 would be 22, you'd need the 1, plus 7 would be 21, you'd need the 4. Both of those are possible, so I'll just mark a 5 in there. That didn't resolve. 9, 7, 8, 6. How about this? That's interesting. It's got to be big enough to... It's not consecutive, so it's not 7, 8. So it uses 1 of 7 or 8. 8 and 3 would be 11. That's possible. 7, 4 would be 11. So that's also possible. It's got to be one of those, though. So where do 1 and 2 go in this row? 2 can't be there. It can't be in there. It's in one of these two. What about this 4, 3? They must have... They can't have 5, 6 because 6 goes there. So they must have a 2. So it has to be here. Okay. And then this one is either 1 or 5. It's not 1 because 1 goes down there. So it's 5. 5, 2. Okay, 5 comes out of there. 3, 4 that's a 5 rather. That's why I should be making that. Those don't have a 1. They're what, 2 and 9. 5 has sorted out that. Sorry, there's probably things opening up everywhere, but I can only look at one place at one time. So let's put in what I can. Lots of these pairs down here are being resolved. That's good. No, that stuff's still not fixed. Yeah, that 9-2 pair is solved. That fixes the 9-5 pair. This must be a 1. There seems to be a 7-8 pair in the column. 1, 2, 5, 9, 6. So this is now still 8-3 or 7-4, irritatingly. This one can't be 3 or 4, so that has to be 7 or 8. And this is a run, so this can't be 6. But it could just be 9. 7, 8 or 9 there. 6, 5, 1, 2, 9. 5, 1, 2, 6, 9. Oh, that's not 5 now. This is 7 or 8 because of the 3, 4 here. This is 3 or 4. Oh, but I mean, they could combine either way to make... Oh no, can they? Yeah, it could be 8 above 3 or 7 above 4. Okay, that's all getting a bit recursive. Now, these single digit 6, 5, 4, 3 are gone. That's got to be 1 and 2. Yeah, I mean, I should have looked at that a while ago. So 9 is there, as it has been for a while, because of that 7, 8 pair that I didn't spot. Surely now we are getting, yeah, 8. This is now a 7, 4 pair. That's 3. Now, these are even together. They add to 18, so that's even as well. Yeah. And that's fixing all these 7, 8 pairs that we've had going on for a long time round to there. Still haven't done these 1, 4 pairs that we virtually started off with. But it doesn't matter too much. We will get to them, obviously. 8 is not in there. 2, 3 is resolved now, so that fixes 1, 2, 5 there, 3, yes, 1, 6, 5 there. Got a 1, 4 pair still here. Now, that will be decided by the parity here. So these add up to 21. We need that to be even to make 25 rather than 22. Okay, so that may be the thing that decides the pairs. 9 is there, actually. This is now 6, 8, 7, 5, 6, and up here, this is obviously 4, so we've got 8, 7 to fix there, 8, 7 to fix there, and 3, 5, 6 to put in here. What a nice puzzle. I have a feeling I've missed various things along the way and done things maybe in a different order from what might be most solver friendly, but at least we get to the right answer. I will check the solution, but obviously it won't be checking whether coloured boxes have runs of digits in and white boxes don't, which is a key constraint. I'm very sure, though, that this is the unique solution. Nice puzzle. Thanks very much, Jeremy, for sending that. And thank you for watching. Hope to see you again soon on Cracking the Cryptic. Bye for now.